Hello everybody, and today we're going to be looking at order of operations and writing expressions. So here we go. So first thing we're going to do is we're going to review Pemdas. Remember, P stands for parentheses. Okay, that's the first thing we look for when we take a look at order of operations. The second thing we look for after parentheses is exponent. The third thing and fourth is multiply and divide. Now again, multiply and divide are of equal strength. So in order to solve this, it's the first one you come to when working from left to right. And then when it comes to add and subtract, the same thing. Because they are of equal strength. Okay. So, order of operations, things you've been beaten with I don't know how many times over your young educational lives. So let's move on. Alright, so applying order of operations. Okay, so let's take a look at this first one. Okay. So, order of operations. So, first thing we look for is parenthesis. Are there any parentheses in this first problem? No. So now we go to exponent. And I see an exponent right here. So we evaluate that first. So 27 divided by 9 times 2 minus 3. Now, exponent is done. Now it's multiply and divide. But notice, we have a divide and we have a multiply. So it's whichever we come to first when working from left to right. So in this case, because I get to the division first, that's what we do first. So 27 divided by 9 is 3. Okay. Now at this point, now we're going to multiply. So 3 times 2 is 6 minus 3. So 6 minus 3 is 3. So there's this one. Alright, now let's take a look at this next one. Okay, now order of operations says parentheses. So the first thing I'm going to do is I'm going to look, these brackets act like a parenthesis, so I start here. But remember that with order of operations, when you look inside a parenthesis, Pemdas starts all over again. So you're looking for more parenthesis. And when you look to find more parenthesis, we have work right here to do. So that is where we are going to start this problem. Okay? So 2 brackets 30 minus parenthesis. Now 8 plus 3 is going to be 21. Okay. Now at this point, okay, we look inside the parenthesis. Have we done all the work in this parenthesis? The answer is yes. So now we could step into this parenthesis right here and start putting all that together. Okay. So when I do that, we're going to have 2. Now 30 minus 21 is going to be 9. And now let's finish the problem with some multiply. So 2 times 9 is going to be 18. Okay? So there's that one. All right, let's move on. All right, more. And we have distribution of fraction. We have all sorts of garbage here. So first things first, start with the parentheses. Let's look here. Is there any work to do inside that parenthesis? The answer is yes. So 3 halves, parentheses. Now, according to order of operations, I'm going to start right here with this exponent. So 3 cubed, 3 times 3 is 9. 9 times 3 is going to be 27. And then while I'm at it, I also can look at this right here too. It's also in the same level of parenthesis. Okay, so 2 parenthesis, and 1 plus 2 is going to be 3. Okay, now, looking at the next part of this problem, have we done all the work in this parenthesis right here? The answer is no. So we have more work to do. So we're going to have the 3 halves still there. Now 26 minus 7 is negative 21. But when I look in this parenthesis, is there any more work to do? And the answer is no. It's all done. So therefore, that stays as is right now. Okay, now, then we're going to look inside the parenthesis. Is all the work done in this parenthesis right here? Yup. Is all the work done in this parenthesis right here? Yup. So now from there, now we can look outside. We now look at this whole problem here and keep applying Pemdas. So according to order of operation, my next thing to look for is exponent, which is right here. So we have 3 halves times negative 21 with negative 2 times, now 3 squared is going to be 9. All right, now we go to multiply and divide, multiplying fractions. So we're going to use the check trick here that I call. Okay, so what you do is we're going to multiply the top here, and you get an answer. Okay, then with that answer, we're going to come back and we're going to divide. Now, if we get a nice number, great. If we don't, we write the ugly fraction. So here we go. 3 times negative 21 is negative 63. We're going to take negative 63 and divide it by 2. Does that come out nice? The answer is no. So you're right, negative 63 divided by 2. Now over here, we have a straight distribution. So negative 2 times 9 is negative 18. Oop, gotta shrink it down. Now, at this point, remember, in order to add or subtract fractions, we have to have common denominator. So, common denominator, so we have a 2 and we have a 1. So common denominator is going to be 2's. So negative 63 over 2 minus 36 over 2. And now that we're set, we can go across the tops here. So 36 and 63, that's going to be negative 99 over 2. Now, depending on your teacher, I think these are okay. So that would be the answer I would accept. Some teachers may say, nope, 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 you have to put it in proper form. So how many times did 2 go into 99? That's going to be 49 times with a remainder 1/2. So again, depending on your teacher, I think this run right here. I think this is okay. But again, some teachers may say, nope, you got to put it in proper form. So that's up to your teacher. All right, let's move on. All right, evaluating. This is using substitution. So I'm told that x is 4, and to this problem, 3x minus 8. So everywhere I see x, I'm going to replace it with 4. So now we're going to solve it out. Parenthesis, can I do anything? No. Exponent, no. Multiply, yes. So 12 minus 8. And 12 minus 8 is 4. So we got that one. That was easy. This next one, a little trickier. We have 3w squared plus 5w minus 3, where w equals negative 2. So everywhere I see w in that equation, or actually expression, we have to put negative 2 in. So 3 times negative 2 squared plus 5 times negative 2 minus 3. And now we follow Pemdas. Parentheses. Well, I got parentheses, but they're not doing anything, so I don't need that. Exponent. 3 or negative 2 squared is going to be positive 4. Plus 5 times negative 2 minus 3. Now at this point, 3 times 4 is 12. 5 times negative 2 is negative 10 minus 3. Now add and subtract. So 12 minus 10 is 2. 2 minus 3 is going to be negative 1. Now again, with stuff like this, it's just a matter of taking your time, okay? Alright, so let's move on. So, taking a look at something like this with fractions, first thing we do, again, we're going to put the 7 in for the x's. So on the top, we're going to have 5 times 7 minus 12 on the top. And we're going to have 2 times 7 plus 9 on the bottom. Okay? So now, we're going to distribute the top. So that's going to be 35 minus 12. And on the bottom, 7 times 2 is going to be 14 plus 9.
Here are some of your photos. By the way, you can ask me to share a photo with your
35 minus 12 is going to be 23. 14 plus 9 is going to be 23. So reduce the fraction. 23 over 23 is 1. Alright, so let's talk about in section 1.3, we're writing expressions. So a couple things we have to watch out for, like addition. You know, you see things like the sum, plus, total, more than, decreased by, or increased by, sorry. Okay. If we're talking about subtraction, typically we see difference or less than, I forgot a comma in there, or minus sign, or decreased by. Multiplication, you see the word times, product, multiplied by, and of. And then with division, you'd see quotient, divided by, or divided into. Okay, so these are all phrases that are used to describe these functions, so you need to know these. So make sure that you jot those down, take a picture of the screen, do something, because you are going to see a lot of this in the next couple of slides and in the future. Alright, so let's move on. Alright, so now in these we have 3 key phrases we have to be very careful of. The phrases less than, more than, and subtracted from. Okay? When we see these phrases, it tells us we need to switch the order of the pieces in which the pieces came. So let me explain. Okay. So looking at this first one, no, I don't like that. So looking at this first one, it says 4 less than 3 times a number. Okay, so first thing we're going to do is let's pick out all the math terms. So we have 4. Actually, you know what? I'm going to zoom in. Hold on a second. Okay, so we have 4. How do I represent 4 in math? It's with a 4. Hi, Gwen. Stop spitting. That's gross. Okay. Then we have the word less than. Now that does mean subtraction. But I typically do like a little star here to remind me there's something wrong with this. This is one of those 3 phrases I have to watch for. Okay. Now continuing on. 3. Well, how do I represent 3 in math? Is with the number 3. Times means to multiply. A number, I can use any variable I want, so let's use x. I'll be boring about it. Okay. Now, then we have to piece this all together. So we have 4 subtract with this little doohickey thing right here. 3 multiply x. What would be the easiest thing to put together would be this, right? Multiplying 3 and x. So 4 subtract with the little star doohickey thingy here. And 3 multiplied by x is 3x. Now that I can't do anything else but deal with the subtraction here, okay, the little star or asterisk says we're going to flip the order in which these pieces came. So this 3x is going to go to the front. This 4 is going to go to the back. And then I can make this a subtract. So this is going to be 3x minus 4. And that's what we have to watch out for, the switch that has to occur with this. All right, let's take a look at another example. So I'm going to zoom this out, bring this over here, zoom it back in. All right, so starting off, 3 times a number more than 4. Okay, so we start. So 3 is 3. Times means to multiply. A number, I don't know what it is. I'm going to use y this time to be a little different. More than is addition. But again, I'm going to use my little star here because that's one of my catchphrases. And 4 is 4. So just like the last one, first thing I'm going to put together is 3 multiply with y. So that becomes 3y. Add with the star and 4. Okay, now let's deal with this. So we're going to flip-flop. So the back goes to the front and the front goes to the back. So 4. Then I can make this a plus now. And 3y goes here. And there's that. Okay, so it'll look like that. So I'm going to back out so people can see everything again. All right, so let's move on to the next slide. All right, so we're going to do some translation here. Now again, anytime you're dealing with a word problem as simple as this or as difficult, always read the stupid thing first. Don't do anything else but read it. So 3 times a number, x minus 5. There, I read it. All right, now my next step, let's start our translation. So let's start with 3. How do I represent 3 in math? Is with a 3. Times is multiplication. A number x. Minus, so subtraction. And 5 is 5. All right, so now I broke this down into 3 multiply x subtract 5. So we got to put this all together. So where do we start? Do I start with the 3 multiply x? Do I do the x subtract 5? Well, again, multiplication is a more powerful function here. So we're going to go with that first. Oops, hey, stop it. So we're going to show the 3 multiply x. So that's 3x. Okay. And now let's take care of this. 3x minus 5. All right, so there's that one. You should get that. Okay, so let's go to the other one. Now this one we got a lot more involved with here, so we got to be careful. 3 times the sum of 7 and a number y. So start our translation. 3 is 3. Times means to multiply. The sum is addition. Of 7. And the number y. Now, when we look at this, we're looking at 3 multiply add. So we're going to ignore this part right now because I can't 3 multiply add something. So let's take a look at this. Add 7 and y. That makes sense. I can do this. So let's take a look and do this out first. Okay. So we're going to do 3 multiplied. That didn't change. But to show the addition of 7 and y is 7 plus y. Now I have to multiply 3 with all of this, not just the 7. We're doing the 7 plus y, which means we're going to need to use parentheses to do this. So I'm going to put the 7 plus y in a parenthesis, and I'm going to put the 3 out in front. And that's how that one looks. So I'm going to back out so you can see the previous problem and this one before I move on. So you have everything you need. All right, so let's continue onwards. Okay, real life translation. Okay, to get through the toll booth, you need 8 quarters. Okay, so they want you to translate that into what that means. So first off, you have to declare your variable. So let's say we're going to make the letter Q equal to quarters. Okay, so to get through the toll booth, you need 8 quarters. So to do that properly, as if you went through the toll booth one time, you need 8 quarters. If you went to twice, you need 16. And then 3 times would be 24, and 4 times. So you got to think about what's going on here every time you try to solve or do what this thing's asking you to do. So in this case, to write this into a translation, we would say 8Q, right?
Daddy, it's nap time.
It's nap time? Well, that's wonderful. All right, so let's move on. All right, last thing we're going to talk about is unit rate. Now, the definition itself is rather confusing, but I'll explain what it means in a minute. It says, a unit rate is the comparison of a certain amount of item A when compared with 1 unit of item B. So most people sit there and go, what in the world does that mean? Well, here are some examples of unit rate that we use all the time. Stuff like miles per gallon. This says we go X miles, or however many miles, on 1 gallon of fuel. Okay? Because we're comparing the number of miles to 1 gallon of gasoline, that's actually a unit rate. Another unit rate that we see a lot of is beats per minute. So dealing with the heart or something like that. So you're going to have the number of beats for every 1 minute.
Daddy,
What,
Daddy,
Gwen?
it's nap time.
It's nap time? That's wonderful. I wish it were nap time. If my students are still listening to this, they're probably napping by now. Now, don't mind my 2-year-old. All right, moving on. So in another one, miles per hour. So we're going to do the number of miles for every 1 hour you travel. Okay? Now, you're going to be given in your homework tonight stuff like this. Like, say you were doing, let's say your pay. That's another unit rate. So let's say you got paid $180 for 10 hours of work. And you're asked to find your rate of pay. Your rate of pay is typically given in money, the amount of money you make every 1 hour. So, the easiest way to do something like this is to calculate your rate, any unit rate, is you take the top number and we're going to divide it by the bottom number. So for instance, in this case, 180 divided by 10 is 18. So you would have $18 an hour. That would be your rate of pay, which is indeed a unit rate. Okay, we'll switch this down again. Scooch this over here. Okay, we'll do this one. Do another example real quick. So let's say we traveled 250 miles. Miles, if I can write that nicely, that'd be great. On, say, I don't know, 4 gallons of gas. Okay, we're driving a Prius. Okay. So, what we're going to do to calculate the number of miles you can travel on 1 gallon of fuel is we're going to divide 250 by 4. Okay. So when I do that, you're going to get a decimal, and that's okay. We'll round it to 2 places. So, let's see. We would get, let's see, 250 divided by 4. So, you get 62.5 miles for every gallon. I'm teaching a lesson to my students, Gwen.
Now draw it.
I did. See, I drew it.
Now drew blue.
Well, I'll do it on the next slide. How about that? I got to change the slide. People are sick of looking at this. All right, so kind of like what we were just doing on the previous slide, and per Gwen's request, I'll write in blue.
Write in blue?
Yes, I'll write in blue. Okay, so we're going to do a unit rate of 32 students in 4 groups. Okay, so they want us to do the number of students in 1 group. So all we're going to do is we're going to divide 32 by 4. And we get 8. So you're going to have 8 students per group. That is a unit rate. All right, next one. We are going to compare 50 miles on 4.5 gallons of fuel. So we want to know how many miles you can go on 1 gallon of fuel. Okay, so here we go. So we're going to take our 50. Here, let me change color. So we're going to go 50 and divide by 4.5. And when I do that, we get 1.111111111. So we're going to round that to 2 places. So we're going to do 11.11. And you can have a unit rate as ugly as that. Okay? And there's our unit rate. Alright, so that's the end of this video. Hopefully you learned a lot, and I'll see you next time.